So, hey, IT 380. So we're starting up sprint two. Move it up a little bit here. So I delayed the start by a week. So sorry about that. Just exhausted from the baby. Um, so I did trim a week off the semester, and I'm going to get rid of the midpoints. I'm just going to grade at the endpoints of sprint two and sprint three. It's just the reality of the amount of energy that I have. So as you can see, here we are at by the time you watch this, anyway, it'll probably be Monday the 12th. Right now, it's Sunday, October 11th, and we're going to start sprint two, and we'll get up some details of what it will look like for you to deliver it 4 weeks. But basically, you're going to create a design document following your research document, basically detailing a solution to the problem that you've explored, and then you're going to build that level one of the prototype. So I'm going to be going through bubble sort, and I do realize we have a wide range of experiences in the class, and I'm not going to be able to tailor to everybody. So I'm going to just have a few ways that you can complete the class. You can choose to follow along with me with bubble sort, and you still have to do all your documentation for the design document yourself, and you still have to write the code from the project, but you're basically following along with me in the videos. And that's somebody who's completely brand new and completely feels overwhelmed with everything, and you can completely choose that path, and that's fine. And then another type of student, feels more comfortable, may have taken a few Unity classes at NJIT, and they can choose to continue within the same structure that I'm doing. But you still have your own problem, your own solution that you're moving towards. But you're still rebuilding a prototype that has the intro and the tutorial and the level one. And you're still going to build your design doc, but it's toward your own game. And also for those who are trying to do that, but ultimately hit a roadblock down the road, and they realize they went down too many rabbit holes and too many tangents, and they thought they were going to make this very sophisticated prototype, and it's just too much, and the semester's winding down. At least you can fall back into my project, which that happens too as well. So either of these paths are correct. It's about the effort that you're putting in and the growing of your skills that's going to determine your grade. So sprint two is all about designing the solution for the problem that you've explored. So here we have week one, week two. I'm starting to figure out some readings. The weeks up on the canvas aren't filled out yet, but at least we're getting our video going for the week, and we'll figure out which readings are appropriate per week. But now we're down to week four, and this will conclude my lecturing, and this will conclude my wrapping up of the design document. This will conclude my work on the prototype, and again, there's this week five where it's you have a week left. I'm not going to give you any new material. You still have a week to complete stuff. And for most, you will take that week to continue working. But if those who choose to, they can either go work at another class or move forward into sprint three. So then sprint three will start here. So we're ending sprint two. Remember, there's one endpoint now, no midpoint. So the endpoint's going to be worth 30 points. Because basically, you're just getting one grade for your 4 weeks of work or 5 weeks of work instead of the 2 grades. It's just real, just the logistics that are happening now that I'm just not going to be able to grade every 2 weeks. So sprint 2 ends here. What's that? November 8th, and then we move on into starting up sprint. Do I have my numbers right? Yeah, I think, okay, right. Tuesday the 10th, right. So we'll start up the next week on sprint 3, and this is just, we've done our research phase, we've done our design phase, and you've kind of built 2 parts of the prototype, and now you're just working on wrapping up that last big part of the prototype and finishing up any tweaks and additions to it. And so this starts kind of mid-November. We have 1, 2, 3, and then the 4th week. And so there's the endpoint deliverable, another 30 points. And if you remember, 10 points just for all of your class participation and what we think about your final presentation and project. And then here's our final like presentation day. So now if I go back to sprint 2, we're going to be kind of reviewing what we were working on during our computer science educational technologies of Cspresso, this binary counting, in both like VR format, AR format, and then the bubble sort. So we're going to be explaining what was happening to us as we were exploring this solution space, and we're going to be showing some of the design documents, and um, you will be writing a design document with very similar sections. So as we kind of move through our own design documents and explain why we wrote what we were doing and why we were moving through the learning objectives and the gaming objectives, at least these sections will make sense to you, and you can connect it to an actual real working prototype. In this case, the binary counting we're going to be talking about mostly. And then you can then explore your own solution, or as I said, there's the alternate path. You can follow along with me with Bubble Sort, and you can write your own design doc for Bubble Sort, or choose your own game, as most of you might be doing. So, actually, this slideshow is pretty useful to talk about. I've talked to some people through when I've introduced this project, they use this slideshow, and it seemed to work well. So this is Espresso. This was the ending high fidelity, like ultimate finished graphics. You're not going to get to that point, but we did like a second iteration on our prototype. This is what it looked like, moving around these stations with Eggy. But ultimately, what's more important is these are our UX design artifacts. These are diagrams and images and storyboards and animated GIFs and writings that helped explain our ideas to ourselves and others as we started to generate what this prototype might be. And so we looked at this idea of binary counting, pulling these levers on these machines to represent zeros and ones, which are the essence of how electronics or our computing machines keep track of different programs that are running on it. So in this case, there's a bunch of stations. We thought that this is what we're calling a user path diagram, how the user would move through it. So normally with mobile apps or websites, they show diagrams moving through some of the parts of the apps. And actually, this is quite literal because this isn't virtual reality. This is literally how the user is moving through the three-dimensional space, moving through the experience with their own feet. And so here's one of our early iterations where the user's starting at the top part of the circle, and they're moving down through the stations. They're selecting different components and attributes of what their final output is going to be using all these levers that you can see at the bottom. So it's a fun, interactive, a very visual, quick, responsive way to see when you're pulling these levers back and forth what's happening. So, for example, the number station, how many numbers of objects do you want to generate? Well, pulling all these levers generates different numbers. It's pretty straightforward. And then next would be the color station. Which color do you want these objects? And so it gets a little one step off, a little bit harder. Can you translate these levers into the bits that they represent, into the numbers that ultimately represent like an atlas, each one representing a color. And then later on, if you see in this early iteration, version 1, we had a size and a shape. And then this help station if you need it, and ultimately coming to the middle. So I'm going to click on this one because this is what we ultimately ended up with. So a few changes as we started to build this in VR, we realized that you can't really start at the perimeter of your experience the way the standing VR works. You kind of have to be generated right in the middle of your play area. So that's why the user is generated in the middle. We removed and revised some of these stations. Some made sense, some didn't, as we were actually prototyping. Actually, we're coding. And I won't say what made sense and what didn't make sense. It's more like what's hard and what's easy. So where's that low-hanging fruit? Where can we get the biggest bang for our buck? Where do we think there's a lot of educational value in the station that's the easiest to build? And so some things got lost along the way, like the help station, this size station, and we found that spacing the stations out this far through repeated user testing made a lot of sense and felt well. We also had this exterior wall. This are like, if you could see this wall in the background in our animations, this is the boundary of the space that actually where the physical boundary of the VR space, you couldn't walk past it anymore, or else the VR experience would end and the cameras would come on the equipment. You would just see the world around you because you're leaving the safe space. We had a real computer graphic wall too, so it stopped the user twice as much. Like you don't feel like you're going to walk through this virtual wall. It feels uncomfortable. So this is a very good diagram, and you'll see this in our design document. So this is called experiential learning. And the core of it is you learn something and then you practice it. So you don't just sit there with a lecture going on and on and on about a new topic, because eventually you just keep forgetting. It's just like storing it all in your memory, and eventually it's just going to leak out. There's no application to it. There's no rhyme or reason to help practice on it, to help kind of imbue it into your long-term memory. So you get introduced to something, you learn about it, you practice it, you apply it, you demonstrate the skill set. You demonstrate that you understand it. It's like the test at the end, the assessment. And if you look at the orange parts, might be a little small, but you can zoom in. But anyway, this actually has statements relating to our actual interactive experience. So Eggy being the guide character that gives a tutorial and guides you through. Eggy shows the user the station, gives direction of what to do for that task. So they're getting introduced. Then users guided through the binary math exercise. Via tutorial, our following prompts are learning. User is given opportunity to bring out the task demonstrated in previous step. So they're actually practicing with the stations, and it's an open-ended situation. The station doesn't like clamp down or shut down after they interact with it. They're allowed to continually try different answers, and then they have to go move through all the stations before they execute on it, before it becomes a final answer. All right, so users apply. User receives validation of the understanding once completing the task. So they have to go all around the loop. And here, actually, in this one here, you see it. You generate your output, and you're bringing it to the task station. And then you pull this lever to send out this is what you think is the finished output, and send it out and see what happens. And you're either right or wrong, and you get a little hint if you're wrong. So you must have to kind of execute on your answer and see if you're right. And then demonstrate. You demonstrate your understanding of the binary math concepts by completing the task successfully. So we had a tutorial, almost like an intro, just get used to this world, look around, play with it before you actually have a structured tutorial. Hey, look, you have to pay attention to me. We're going to move you around this world. We're going to introduce you to each of these stations. What's the point of this place? What are you trying to fix? What does each station do? How do you execute or try to fix or complete a task? And then we give them a series of tasks that range up from easy to difficult. And then once you complete the difficult, you've demonstrated that you understand the concepts. In this case, a string of 3 bits. And so we start with a very simple task, and the user must keep iterating on that one task until they get it right, and then they have task 2 and 3, and we tried to figure out what each step of the task it meant to make it harder and harder. So here the designers are in the mixer lab, figuring out the main loop and the structure of the experience. But you see that there's no computers, they're not programming. they're talking and they're exploring and they're writing their ideas down on the whiteboard. And there's a lot of props, that anything we could grab around us that were very quick and easy to try and demonstrate. So in the world of games or in educational games, we have what's called paper prototyping. And so we'll try card games, board games, dice games, cut stuff up and use it. Anything that's super fast to use and cheap, because you have to iterate very fast and just move to other subsequent ideas. So here we have the number station, and this is the first iteration, our first few iterations on it, and we were just using a whiteboard, a portable one, and just using a marker and using sticky notes and anything we could to just try out, what does this feel like? What does it mean to switch a lever and for these numbers to represent? And here's a similar layout, but we're on a table, and you can see those little sticky notes here, and we're just using index cards. And we're actually just like drawing out the number. What does it mean if this lever gets pulled down in this one? If it's 0 on 1, and we did the math, and that would be this. And so you see it's very low tech. And then here's like our task station, our send and receive button. And this went through a lot of iteration because this starts and ends the whole thing. So we really thought about, what does it mean to receive a task and to send a task, to start to end, to be given a question and to give back an answer. And this is where we spent a lot of our time, because this begins and ends just the whole experience and all the tasks. And here's a different iteration of it. So here's the beginnings of like diagramming out one of the stations and then actually building them. So here at this point, I think the only thing I was really interested, so let me just briefly talk about that. I know that storyboards and other pieces of concept artwork, or actually making higher end pieces of graphics, are beyond the capabilities of this class, and that's not the point of this. But I just wanted to show you that they are super important, and that later on, if you do have work in smaller teams, or do actually have teammates who might be able to create content like this, or UX artifacts like this, they're really important to help express ideas to the team. And here we have an interaction storyboard, how the first interaction would happen, how the user enters this world, how's the world presented to them, what is like this lit path on the floor, this guiding way that there's only one thing that they could hit, this one run button that kind of starts up the intro to the whole experience, and what this little character is that kind of guides them to it. And without something like this, I would not be able to program it as easily. Yes, you could describe all this in words, just a big text document, but you can see that a picture is worth 1,000 words, and why that metaphor exists. There's 9 panels, just tells me a lot of how to build this first part of the experience. And this is a UX storyboard on using the number station. So it's another interaction storyboard, and it might be hard to see, but so I'll just describe it. The Eggy's showing you how to use your hand controller. With the station, he's introducing the station. This is what the user looks like outside VR, what they're looking in at. This is the user getting close enough to the station to understand that there's an interactable, and here's the user actually using it. So it sounds so simple, like we're over demonstrating the simpleness, but that's the point. You don't want ambiguity. Here's the lever in the off station. Here's the lever in the on position, and it's a simple rotation. Sure, but just to see it expresses so much to the programmer what the intent of the interaction designer meant. And as you pull the lever, the number wheels turn. That's what this is representing. So there's some parts of the machine that change as an interface as the user's interacting with parts of it. And success, and Eggy is saying success. So The rest of these images are great and everything, but I just wanted to show you the core of what we were thinking with this before I just move deeper into the design document. The point of this was just to kind of reintroduce you back into the class, into Sprint 2, reintroduce you back into the projects that we're using as samples in our thinking as we were building it. And yes, this is in 3D, yes, it's in VR, and you're not doing any of that, but all the core principles still remain. You're doing web-based 2D or 3D. Actually, since I'll be doing bubble sort, you'll be doing introduced at least to web-based 3D. But again, 2D, 3D, monitor-based VR, it really doesn't matter. Like the fundamentals are the fundamentals, and they're expressed throughout all these platforms. And so the next video, let's go in depth into the design doc.